The shortest side of a triangle has length 14. The other sides have length x plus 1 and x plus 3. Find the value of x that would make the triangle a right triangle and give the length of each side. So let's draw a triangle. We want it to be a right triangle, so I'm going to go ahead and draw a right triangle, although it's not right yet. The shortest side has a length of 14. The other sides have length x plus 1 and x plus 3. Which one do I put where? If it's a right triangle, it's got a hypotenuse. If it's got a hypotenuse, then that has to be the longest side. Yep, very good. So x plus 3 has got to be the hypotenuse, and x plus 1 is the leg. Now, we did Pythagorean Theorem converse yesterday. So we learned a triangle is not a right triangle unless a squared plus b squared equals c squared. So that's the key to turning this triangle into a right triangle. So let's find out what x is going to be. We're going to force a squared plus b squared to equal c squared. (14 squared), 196. X plus 1 squared. Don't say x squared plus 1, because you do have to FOIL. You have to FOIL it. So that would be x squared plus 2x plus 1 equals, I'm going to FOIL this one as well. You can use the box method if you need to. X squared plus 6x plus 9. Let you digest that for a second unless you already got it perfectly correct. The great news about this is we've got on the right, and we've got an x squared on the left. And the great news is those cancel. Yes, I was. So when they cancel, that means we no longer have to factor. Factoring is off the table. Yay! I hate how this screen doesn't get longer. I have to drag something down there to make it longer. Silly, silly. Okay, so we've got on the left side, we've got 196 plus 1. So we've got 197 plus 2x equals 6x plus 9. Subtract the 2x, subtract the 9. 197 minus 9. $188 equals 4x. Are y'all with me? Are you already done? Are you bored? X is 47. And then I would plug it back in and make sure that it makes sense and that it works. So we've got 47 plus 1. Obviously, why did I put that in my calculator? 48. And we've got 47 plus 3, 50. So is that a Pythagorean triple? 14, 48, 50. 14 squared plus 48 squared is 2,500. 50 squared is 2,500. Yay! There's a new Pythagorean triple to memorize. 14, 48, 50. Questions on this warm-up on how we did that? A lot of it was algebra. The setup was geometry, and really the rest was algebra. This is the answers to the Pythagorean Theorem worksheet number 2. It was the converse. It's Pythagorean Theorem number 2. You got some for me to work? Acute is when c squared is smaller. Acute is when c squared is smaller. 8 and 14. And 4. Okay. Guys, we do have a quiz today. Okay, let's do those. 4, 8, 14, 15. Okay, starting with number 4. Number 4, you need to draw an altitude. Because we cannot use Pythagorean Theorem unless we have a right triangle. So when you don't have a right triangle, you need to make yourself a right triangle. So I know if this is 4, then this is 4. 12 minus 4 is 8. So that triangle right there has a side of 8 and a side of 6, and there's a Pythagorean triple, 6, 8, 10. That picture was really small. Did you see what I did? Okay. Number 8. Let's see if I can zoom in before I... That might be too much. Anyways, number 8. So we've got a trapezoid here. We need to find x, and we're going to use a right triangle. Remember, you need to look for those right triangles because we are learning about Pythagorean Theorem, and you can only use those on right triangles. So we're going to focus on this triangle. We know that. That's 8. We need to know the other part of the right triangle. But what we can do is take the 18 root 2 and subtract the 16 root 2, and we'll be left with, hopefully, 2 root 2. So now we need to do Pythagorean Theorem. A squared plus b squared equals c squared. All right, 2 root 2 squared. Let's see, 2 squared is 4. Square root of 2 squared is 2. So I've got 8 plus 64 equals x squared. 72. Then we need to factor tree the 72. And we should get 6 root 2. So x squared equals 72. X equals the square root of 72. You factor tree it, or you go to your calculator, whatever method you use, and you get 6 root 2. Okay. So there's number 8. What's next? 14, and then 15. Okay. Okay, so, we're going to learn about this today. 14 is going to be so much easier after today. Okay, I don't need to do 15, thank you. Okay. What you would need to do on 14 is call this A and A, because there's tick marks there, so they're the same length. So, A squared plus B squared equals C squared. So that's 2A squared equals, let's go ahead and square this. 11 squared is 121. Square root of 2 squared is 2. So 121 times 2, 242. We're going to divide by 2. So it's kind of canceling it out. So we're back to 121. And then we take the square root. You're going to find out why this is happening later today. And A ends up being, lo and behold, 11. So now we've got this right triangle right here, and we've got a side of 11 and we've got a side of 12. So we'll do 12 squared minus 11 squared, and we'll be taking the square root of that. 12 squared minus 11 squared is 23. 23, there's no factor treeing to that. Okay, So that was 14. All right, let's get into today's lesson. Which is, today is all about shortcuts. So we're going to focus on one type of triangle today. But the reason we're going to focus on this one is because it comes up a ton in the real world and in our geometry worksheets. It comes up a ton. So this triangle shows up a lot, and there's a shortcut to help us find the missing side so that we don't need to do Pythagorean Theorem every single time. So today we're going to discover that shortcut. All right, if this triangle is right and isosceles, mark the appropriate sides with tick marks and fill in the angles. So where would I add tick marks? What markings would I add to my picture? Yep. So it's isosceles and it's right. So the triangles we're going to learn about today have to look like that. They have to be right and isosceles. One of my students one year nicknamed them isosceles triangles. Right, isosceles, isosceles. We know that this angle is 90, obviously. What are the other two angles if it's isosceles? Good, George. Okay, good. So these, by default, have to be 45 and 45 because you have 90 degrees left, and those angles are congruent because it's isosceles, so 90 divided by 2 is 45. So today, we're going to refer to our angles, or to our triangles, we're going to call them 45, 45, 90 triangles. 45, 45, 90 triangles. So when I say that, you now know that I'm talking about the angles of that guy right there. When I call something a 45, 45, 90 triangle, I'm talking about that triangle. Okay. Use Pythagorean Theorem to find the hypotenuse length. Leave it as a simplified radical. So, everyone pick one and do it. Someone pick A, someone pick B, someone pick C, someone pick D. Everyone pick one. Call it on the chat so we can make sure we have them all covered. George has C. A lot of people have A. Some people, there's going to be more than one person doing one. C. We need someone to grab B and someone to grab D. Okay, Albert's got D. Who's got B? Rose? Okay, Jenny? Okay. When you have your answer, please type it in the chat. You're finding the hypotenuse. So if you're doing A, this is what you're doing. A squared plus B squared equals C squared. And you're solving for C. You're solving for C. You're solving for C. You're solving for C. George, okay. George got square root 2. Yeji got 5 square root 2. Not quite. Try D again. Yes, Austin, yeah. For B, you got 3 root 2. Okay. Now, when something happens twice, you think of it as a coincidence. But when something happens 4 times with 4 different numbers, you might think, hey, this might be more than just a coincidence. This might be a rule. Do you see what's going on in all 4 of these triangles? Look at A. 5, 5, 5 root 2. Look at B. 3, 3, 3 root 2. Look at C. 1, 1, 1 root 2. Look at D. X, X, X root 2. This is not a coincidence. This happens every single time. So if our triangle is a 45, 45, 90 triangle, we don't have to do Pythagorean Theorem ever again because we have a shortcut. So write this in your notes. This is the rule for 45, 45, 90 triangles. It's X, X, X root 2, where X can be any number you want. It can be an integer, it can be a fraction, it can be another radical. X can be a radical. It follows a pattern, which is an awesome shortcut. It makes our life a lot easier. So write this down. This is also on your formula charts, your star formula charts, if you were wondering. This is something that does show up on that. X root 2. I'm going to move on. I'm going to show that clip at the end because I don't want to run out of time, just in case. So here's how it works. If you're missing the hypotenuse, you multiply a leg by root 2. So if you're missing a hypotenuse, I call it you're going forward. You're going to multiply. Like the leg is 3, so you're going to multiply. So the hypotenuse would be 3 times root 2. So if you're missing the hypotenuse, you multiply. That's the easy one. If you're missing a leg, you need to divide by root 2 because you're going to be going backwards. So if you're missing a leg, if the hypotenuse is 7 root 2, you divide by root 2, and your leg ends up being 7. If you're going forward, you multiply. If you're going backwards, you divide. Forward, multiply, backwards, divide. It'll make more sense once we try some problems. Austin, are you requesting to share the screen? Did you accidentally press that? Okay. All right, find A. Super easy. Yep. 9 root 2. You take the leg and you multiply it by root 2. 9 root 2 is the answer. Whew, that was an easy problem. Okay? Yeah. 2 root 2. Technically, although I know you're not really doing this, technically you're dividing by root 2, and they cancel, and so that side is 2. I know you're just looking at the number in front of the radical, but that is what you're actually mathematically doing, and you're going to need to know that for later. Don't say 5. You feel like you're watching a Dora episode now because it's too easy. That's cute. Okay, I'll make it harder. Your wish is my command, Austin. Hussein, no, Taha, those are not final answers. You can't say root 4 is your answer. There we go. X root 2. 5 root 2. 5 root 2. 5 root 2 root 2. 5 root 4. 5 times 2. The answer's 10. The answer's 10. 5 root 2 is really 10. Because square root 2 times square root 2 is 2. Uh-oh. Our hypotenuse doesn't have a root 2. So you can't just take the coefficient of the root 2. You can't just take the number in front of root 2. So this is when, good, but that's not a simplified answer, Yeji. This is when you're going forward, you multiply. When you're going backwards, you divide. H is 6 divided by root 2. I'm trying to extract a root 2 out of it because it doesn't have a root 2. So I'm pulling a root 2 out of it. But there's a radical in the denominator, so we do need to rationalize it. Square root 2 times square root 2, 2. 6 times square root 2, 6 root 2. Cancel. Very good. Very good, guys, who wrote 3 root 2. Very nice. So H is 3 root 2. Let's go backwards and see if it would have worked. So that means it's 3 root 2, 3 root 2, 3 root 2, root 2. Does it follow the pattern? 3 root 2, 3 root 2, 3 root 2, root 2. What is 3 root 2, root 2? It's 6. So we did it correctly. Very good. Just got interesting. Oh, man. Yeah, Hussein, yeah. 2 root 3, 2 root 3, 2 root 3, root 2. Very good. See why we had to spend so much time adding and multiplying radicals? Because we needed it. We needed those tools in our back pocket. Okay, be careful. This one is the hypotenuse. So we need to go backwards. We need to divide. To go backwards, you divide by root 2. But oh my goodness, don't rationalize the denominator. Don't do it. Because 6 is divisible by root 2. What is 6 divided by 2? It's 3. So this is 5 root 3. 5 root 3, 5 root 3, 5 root 3, root 2. Okay? Good job. Uh-oh. Does this get bigger? Find the perimeter. Are you singing the Dora song, Austin? Oh, man. So be careful. I see some 45s. Where's my 90s? Where are my 90s? This is not super drawn to scale. So if that's 45, then that one's 45. Because it's across from the, these are congruent. So that's got to be my 90. Three root 2, 3 root 2. So that's got to be my 45, and that's got to be my 90. All right? 3 root 2, 3 root 2, 3 root 2, root 2. 6. This is a parallelogram, which we're going to learn about later, so that's also 6. So what's the perimeter? You cannot add your integers with your radicals. You cannot combine the 12 and the 6. And people do that all the time. Do you know how many people are going to write 18 root 2 later on a quiz? It is not 18 root 2. It is 12 plus 6 root 2. Good. You can, yeah, these can trade places totally, but you cannot combine them. Quiz time.